As we build technology to solve problems in healthcare, there's one really important asset that we can often overlook, or maybe we don't give it enough time of day. But it's super important because if we don't get this piece right, the whole thing falls apart. I'm talking about the network. Now, I'm not talking about your network of people and relationships, but like the internet and the cloud, infrastructure, the way that all the technology connects together. Designing a network in healthcare calls for extra levels of flexibility and adaptability, efficiency and security. Well, with me today, I'm joined by Alex Swan from Extreme Networks. And in this episode, we talk about automation, reducing the risk and operational overhead when adapting to changing requirements, quality assurance, and how it's critical for network management and automation platforms, and how artificial intelligence will transform the way that we manage networks and why it's critical to any network management strategy. Collaboration starts with a conversation, Team HealthTech. Let's make it happen. This is Talking HealthTech with me, Peter Birch, featuring content and community about technology in healthcare. Alex Swan, tell me a bit about you and what you do.
So thanks for having me on. I'm really pleased to be here. So I'm Alex Swan from Extreme Networks, and I'm a technical account manager in New South Wales. I've obviously, as you can probably tell by my accent, I'm from the UK originally, where I spent a large part of my career actually working in defence. So dealing with very high risk networks and classified infrastructure. And believe it or not, I found that there were a lot of parallels in dealing with that than that we also see in healthcare. So and I switched roles slightly and focus on our healthcare customers and applying a lot of what I'd learned in the defense industry to another high risk environment, which was of course healthcare, and anywhere where you need to maintain privacy, patient safety. It really is a genuine consideration for doing things in a secure manner. I also find it the most interesting area to work as a network engineer because it's just so complex and varied in terms of the users, the devices, and the applications that we see in healthcare. So yeah, I've worked a lot with the NHS before making the move down here to join Extreme in Australia.
Cool. And so we're talking about, infrastructure and networks. And sometimes I feel like if you're not in that game, people start to go, like it's kind of it becomes noise. So tell me, give me some context here when we talk about network and infrastructure and stuff. What is that?
I guess you could say it is the critical dependency for just about everything that we do, right? So putting healthcare aside for one moment, but just us talking today or us communicating with friends or just picking up an email or just checking the weather on our phones, all of those different applications all across the network, they all rely on communication from one individual or device to another. And that's the same that we see in healthcare, right? So when we have a clinician checking a patient's notes on a tablet, that still needs to communicate with other devices, with servers, with data elsewhere. So when we think about every single application or device or technology that we're deploying in healthcare today or in the wider world, it's all dependent on network communication. And without it, there would be none of these applications that we use today.
How's it I pay the NBN and I pay Telstra and I don't pay NBN, do I? I pay Telstra and I pay, Vodafone and all these providers of, is that what we're talking? Is this something different to the internet?
No. I mean, it's essentially the same kind of thing. All those providers are providing public network services for individuals, for consumers, and for businesses, of course. What we really focus on is enterprise networks or the networks within inside an organization. So we would be the guys that would work on the design and deployment of a network inside a very large critical hospital, for example.
Mm. And so that's really important because there's, you think about the patient journey, you're going through, you might check in on a kiosk, you might then go to the reception and do things, and there's everything's got to connect with each other in some way, or at least be powered to be able to. I was going to say keep the lights on, but it's to run the business.
Yes, and just thinking about a particular use case in healthcare, picture archiving communication systems, so PAC systems. They're usually the bane of most hospitals' lives because they're so big and complicated and they've always got some kind of performance problem. But what they do really is to take medical images of a patient and they will then take them somewhere else to archive them, to catalog them, to maybe produce them in several different formats, either to be consumed as more like a summary format in a lower resolution, or they may be produced at a very high resolution for diagnostic medicine purposes. But all of that data has to move around between those different things. You've got the modality, the machine that creates the image. You've got another thing, server somewhere that's going to process all of that video. You've got somewhere else that's going to archive it, something that's going to database it, and then eventually the user's accessing that information from different areas. So there's so much network communication, and that's just in one clinical application.
Yeah, and when you think about it from the end user's experience, whether it's the clinician or even from the patient, it's not they're not too interested in the how it all kind of works under the hood. In the end, they want that thing to come up because they've
Absolutely.
clicked on it or they've
I
requested a
you
result.
know,
It
as a
needs to work.
network engineer, I've always said that the very best networks are the ones that no one knows exists, or they're blissfully unaware of that they exist. Because as a network engineer, you never ever have anybody phone you up and say, "Ah, Alex, network's working great today." It's only a problem when an application isn't working right. So the best ones are the ones that get out your way and allow you to do as a user what you need to do, and that usually is at the application level. But there's a ton of challenges behind that we would need to that we would need to address, especially as we see that diversity of devices, different user types, and applications grow. And then where we're accessing these applications from is becoming much more broad and mobile now. So there's a ton of security concerns around the application depending on the type of data. What's it doing? Is it an infusion pump where if the dosage could be manipulated remotely, we had a major patient safety issue? Depending on each of the applications, each of the devices, each of the use cases, we might have to apply many more controls in order to address patient safety or guarantee the performance of the application. Medical imaging example. So that you don't want to get in the way of the user experience. So there's a fine balance to get. Can be very complex in a healthcare environment.
I was going to say, as things get more and more complex and the needs grow, is it just making things more and more powerful? But you brought up a great example of, it's not just about making it go faster and be more capable. It also needs to be more secure and reliable. So there's a lot of
Yes.
complexity there.
Actually, you kind of made me think of a really key observation that I see, especially around that I certainly saw in the NHS and very much in a lot of the LHDs that I talk to here. Is we haven't really fundamentally done anything differently in networking since we first deployed the Ethernet networks in hospitals in the early 2000s, right? So we might have thrown more bandwidth, more ports at networks to cater for this stuff, but we've not really done it in a different way. So we've grown in terms of complexity of requirements that were placed on healthcare networks. But on the other hand, many of these teams that are managing and operating these hospital networks are shrinking in size, shrinking in budget, and they have a lot more complexity to deal with. So they're being kind of pulled from both ends. So I think we are approaching a critical juncture in many organizations where we're at a tipping point. It's becoming too big and too complex to efficiently manage while maintaining security and safety and operation of those hospital networks. So I think it's time for us to think about, are we doing things in the best possible way in healthcare for the network, which is that critical dependency for everything else that's out there.
I want to come to what some of those innovations might actually look like in a bit, but to really go in on the security point for a second, I guess, but also to divert a little bit and think about how healthcare has been delivered in the past couple of years and trends even prior to all of that too, where more healthcare is delivered from outside of the hospital walls, but also as a lot of devices and applications become easier to use for consumers who are also doctors or nurses or admin staff who become comfortable with using software from outside might start to bring solutions into a healthcare system or their own devices or their own platforms or download something. All of these risks coming on, and also it's not as controlled. Is that
Absolutely.
yeah?
That's a really, really good point because it's quite common now. One example that just jumps to mind is things like a patient entertainment system, which always used to be in a hospital a bedside terminal that was very much controlled and
To
and
use the term entertainment loosely, right? That's the
well, yes.
back in the day,
And
yeah.
these days, the expectation from most patients, visitors, is I can just pull out my tablet and I can get on Netflix and I can do it. So why do I need that thing in the hospital? And quite rightly, I've had some customers say to us, "That's what we want to do. We want to allow that in our hospital." But what's the impact of suddenly having that many devices accessing streaming services inside a hospital connected to potentially hospital Wi-Fi for the patients, for the patient to use? And well, there could be a huge amount of bandwidth consumed by that, depending on how many people and what they're doing. But also, like you mentioned, you've suddenly then got hundreds of untrusted devices connecting to your Wi-Fi network. And is that the same network that's being used for clinical purposes? They're the same physical devices. Because if it is, then we must have a way to kind of separate all of these in a secure way. And look, don't get me wrong, we can do that today. Like everybody is doing that in hospitals today, but it's leading to more complexity in the configuration of the underlying networks to support those types of initiatives.
And I think that then brings us to particularly the theme in the last 6 months or so, and it has always been a theme in health, but heightened through some of the more notable cybersecurity threats and breaches that we've had in very big organizations. So no doubt cybersecurity and all of these points would be front of mind for many of the customers that you work with on a day-to-day.
Yes, yeah, absolutely. It's something that can keep some people awake at night. Really concerned about some of this stuff. I mean, we're going back a few years now, but I do remember an FDA notification in the US about an infusion pump where they had identified a vulnerability, which I kind of mentioned it before, which it could be exploited to change the dosage level that it was administering. So that could be a serious patient safety risk. And their advice, or they mandated, at least in the US, and I think in Europe, we pretty much followed the same advice, was that you had to take all of those at-risk infusion pumps out of service. So most hospitals, number one problem is, okay, I can see I've got like 20 of them on an asset register. Are they actually plugged in? Are they actually in operation? Whereabouts are they? So all of these things are not known at that time. Or if you knew where they were, you could at least go and take them out of operation. But then you've got a massive impact to clinical services because you've had to take key pieces of equipment out of service. And actually, there was an alternative method that they said if you had a capability where you could prevent specific types of application traffic hitting it, then it wouldn't be exposed to the vulnerability. So if you had the ability to centrally, as a network manager in a hospital, say, I want to immediately protect all of those devices by changing a policy on the network around it, you could have continued to operate your hospital while mitigating that risk without all the clinical impact. But I think there are very, very few that at that time could genuinely say that they had that capability. And that's the type of thing that I'm really thinking about in terms of automation and security around devices that attach to healthcare networks these days.
Yeah, there's some exciting opportunities there. But just thinking around some of the other complexities too, because we've talked about, the need for growing bandwidth and the security side and the reliability. Another thing that often comes up around complexities in healthcare is in this piece around regulation and contractual obligations and stuff like that. Does this kind of stuff pop up with you as well?
Yes, very often, actually. Couple of examples here. So these are more constraints that we sometimes see around the configuration of networks. So I used the example earlier of a picture archiving communication system, so PAC systems. It's not uncommon to find that a hospital will take a managed service from one of the imaging providers to deploy that, which would maybe include, as part of that one contract, the modalities, the workstations, the archiving service, all the different components that are required. But they may then mandate to the hospital, this needs to be dropped onto your hospital network in these different areas, and I need them all to be connected to each other, but it must be completely isolated from all of the other hospital infrastructure. So they're under a contractual obligation to separate those services because that's how they've chosen to procure those services. So that can be a challenge. That certainly can be a challenge, because as a network operator in a hospital, how do you effectively do that? And then what if there's an abnormal change? It's then huge amount of configuration effort on my network engineers maintaining the hospital just to do that, to maintain the contractual obligations. And other ones could be for regulatory purposes. It may be, depending on your jurisdiction, mandated that for a particular type of device with a particular risk profile, you have to isolate them as well in order for it to operate. Good example of this one actually was a few years back, or again, going back quite a while now, but if you remember the WannaCry outbreak.
Sure. Yeah.
I was
that a few years ago now? That feels like only recent.
Quite a while ago
Yeah,
now.
right.
But
Okay. Time flies.
It's a great example, although Windows XP was way out of support by that time. There were some clinical systems inside acute hospitals in London that had passed their clinical certification. So for them to be approved for use clinically, they had to be on a fixed software version, which happened to include Windows XP embedded. They could not patch it or upgrade it because it would break its clinical certification. So they were left in this position where they know the vulnerability that's actually causing this is that, and I can't patch it because it will break its clinical certification, and it will take the manufacturer possibly up to a year to push that back through and get the whole thing revalidated.
Well, that's so common though in healthcare, is that, and other industries too, but a lot of healthcare is take a really fancy device and then dumb it down to get it down to where it's certified to be used at. Yeah.
Really surprising how many of those very, very outdated bits of software you can find embedded in bespoke systems. So these are all the types of things as well that of the challenges that we as network engineers are having to deal with on the back end. It's interesting how many take a network for granted. And we all have networks in our house and we all just come home and we connect. So I can understand the expectation that network's just basic plumbing. I just need to connect my devices and it should work. But when we start breaking down, a lot of these challenges, especially in healthcare, you start to see where some of this complexity is coming in and why it is such a challenge for many organizations to efficiently deal with those challenges.
Yeah. I could absolutely see why a hospital CIO or CTO or whatever would want a good relationship with, the organization managing their network and maintaining it. It certainly doesn't sound like a turn it on and then give us a buzz if there's any problems. It's ongoing.
I wish it was that simple. I mean, that's always going to be the driving goal, though, right? Because if we can get to that vision while addressing all of those challenges, that's the ultimate goal, really. So for healthcare networks.
Well, actually, building on that point, then thinking about the future of this space generally, where is there innovation to be had? You mentioned that there's a lot of things have been done in a very similar way for the past 20 years. What's the future of this space with networks?
Yeah, so one area that I think is hugely beneficial wherever in any network where there's complexity, be it healthcare, be it critical national infrastructure, defense, whatever, even education, but healthcare is usually the most complex one. There is a lot more value in considering maybe a different way about going for, or a different way of configuring your switched network. So I'll try not to get too technical, but just a quick history on kind of Ethernet networking. Every time we hit a scalability issue, this is the royal we, network engineers, the community, we come up with a new protocol to get over that hurdle. So we layer that on top. And then we hit another scalability limitation. So we need to add something else on. And then we need to deal with traffic in a different way. So we add something else on. So, we've got things like dynamic routing protocols, and then we've got multicast routing protocols. And then now people are talking about overlay networks of VXLAN, which is all dependent on the underlying layers. Any one of those falls over, the whole lot falls down. But we just continue down that path. So while that's fine, and that's the way the industry has gone for years, if we were going to approach this with a clean sheet of paper today, would we do it differently? And I think most network engineers, when you ask that question, would say, yeah, I think we probably would. And so I find one of the most exciting developments in recent years, a different protocol, shortest path bridging. It's a single protocol that allows us to deal with many of those things without all the layers of complexity on top. And essentially what that allows us to do is create an entire network that behaves as if it's one single network switch. So if I want an isolated service to fulfill my contractual obligations to my PACS provider, for example, I can just create a new PACS service. And as a network admin, I can say, I want that to exist here. And I want it to exist on that switch over there and that one over there. And that's my ports for my contract. Plug into those ports is completely isolated and connected in a resilient manner, which will share all available paths for bandwidth sharing. So you get most efficient traffic routing, you get full resilience, and you don't have to manually configure all the switches in the middle. Whether you cross 2 switches or 200 or even more, you've only got to apply that service at the edge of your fabric where you want it, and it will take care of all of the rest of that. So it allows a network administrator to create a network that is incredibly adaptable in a very simple way to changing requirements throughout the life of that investment. So I think that is huge for a lot of customers, especially if we then look at extending that with authentication and automation. Because if we can, when you connect a device, automatically identify, I know the identity of this device, it's a PACS modality, I'm going to automatically connect it to that virtual service. I then don't have to touch it. So I'm getting towards that goal of let's just plug it in, build the fabric, let it establish itself, and then we can automate the provision of the services to any connected device, whether it's a PACS modality, whether it's a lighting control, an HVAC control, whether it's a patient monitor, an infusion pump, a tablet that a patient's brought in to access Netflix at the bedside. That's certainly the goal.
The way you've broken down, how to think about some of these things has been great, because it's become quite evident to me how important it is to have network at the heart of those kind of strategies that you put together in terms of technology and a practice. And it needs a strategy in and of itself, but it's implicit in how healthcare is delivered within a hospital system. It shouldn't dictate how the care is delivered, but it should be able to adapt and be flexible and have that vision for the future for it too.
Yeah, it is, as we said, the one critical dependency. If there's one bit of technology that every other application or device touches at some point, is the network. And it's often forgotten about. But it has just describing what Fabric would do there, the operational efficiencies, just by removing the overhead of adds, moves, and changes on smaller and smaller networking teams with limited budgets. That's huge for hospitals. It's absolutely huge. Then there's the security. Each of those virtual services has no visibility of any of the others. So you're isolating your patient entertainment traffic from your PACS traffic, from your patient monitoring. It's benefits in terms of security, simplicity, operational efficiency. And that's just one piece of technology. There's just one aspect to it before we even get into kind of the overall operational management of a network on top of that.
Yeah, that's so good. Now, look, that's a great explanation of it all in terms of networks and the importance of the networks in the healthcare system, particularly for a hospital. Alex, we'll put the details for Extreme Networks in the show notes of this episode, and for people who want to continue that conversation with you. And no doubt there's more for us to discuss in the future on the show as well. Appreciate you making the time to have a chat, man. Thank you so much.
Thank you very much. I could talk about this stuff for hours, so I'm absolutely pleased to chat to anybody else and carry on the conversation anytime.
Love it. For more content and community about technology and healthcare, visit talkinghealthtech.com.